welcome back to my channel. In today's video I will be showing you my second tutorial on Houdini HtoA 502, where I will be showing you how to create viscous fluids and how to drive shader parameters with that. So on my YouTube channel you can see I have uploaded that video quite recently, and I got lots of feedback on various of my channels on Instagram and on Patreon and all that, and people really enjoyed it and they asked me if I can create a video on that. Here's a more refined version of that same thing. I just played around with a bit more shading, I fixed the popping spheres and all that, and I will be showing you how to create a very similar simulation and effect in this tutorial. So let's just start off to like a disclaimer that I am not a Houdini artist, I am not an effects artist. I'm just learning the software and I'm really liking it, so I will be doing some mistakes or different workflows which might not be correct, but I will just be doing it, and hopefully you will learn something from it. I will be just collapsing a few of those menus just for a bit more room to play with. Let's close this one as well. So I am just caring about those three tabs on the top there, and maybe also just close all of these guys off. So everything is a bit more clean and you can see what I'm doing. So that is my typical UI. So I'm just hitting save, and let's just directly get started so we don't lose much time on this. So if I hit Shift W, I can open up my little scene inspector, whatever you want to call it, and I just want to create a geometry group like that, and I will just rename this to emitter like that. And whatever is in my emitter is my geometry, which will emit the particles. So I want to start off with a sphere. I want to change it to a polygon, maybe a bit more frequency, like maybe 4, something like that. And then I also want to change it up because Houdini is in meters, so I just want to scale down my whole sphere here, like really small, something like that. 0.05 is pretty good. And then I want to move it up maybe by unit of 1, like so. So now it's a bit higher up in the air. Next thing what I want to do is create a transform node, which enables me to animate that independently from the sphere itself. You could do it in here as well, but I just want to have a transform dedicated for the animation. So what I want to do is get some kind of nice motion to it so the particles are emitted very nicely. Before I do that, I just want to quickly create a my object, which is let's say my collision object. So I'm just creating a new geometry here in line, and I just call this maybe collision or collider, whatever you want to call it. And then here I want to create my test geometry. It's a shader ball, which is provided by Houdini. And then for now, this is it, which is good enough. And if I go in the emitter, we can see it. And now I know what I'm working with. So I can actually move the sphere up a bit more. Maybe something like that. And now I just want to animate it. So I'm lazy, I don't want to do keyframes, so I will use sine and sine operations. And I want to go into the translation, and I just want to move it up and down for now. So I go in sine, create it on a frame, $F reads the frame, and if I just do that, you should be able to see that it goes up and down. And obviously we want to control the speed and all that. So first of all, let's adjust the range by multiplying it by maybe 0.01. So that is our maximum height. And now we want to increase the frequency. So we multiply this maybe by 15. See what that brings us if I hit play. Okay, that's very fast. So I guess we should go a lot slower than that and reduce that by maybe, let's try 5. See what we get now. Okay, and now let's speed it in real time. So if you click that clock on the bottom, it just forces it to limit to FPS. So this is actually now a bit slow maybe. So let's go back up to 10. I'll just see what we get now. All right, that's pretty cool. Now we do the same. We just copy this same function for X, Y, and Z just to give some variation to everything. Now what we have is something very linear. We definitely want to mix it up. So let's just try maybe a value of 2 for the speed on my X and not move as much, maybe 0.05 on X, and maybe go a bit faster than X. Let's just do 5, And maybe do the same offset though, because it is a sphere we're emitting on, so it should be the same. Let's hit play and see what we get now for motion. So this is kind of random motion. It's going in all the axes. And I think this should be good enough for emitting particles. Let's just change the range to maybe 100. So now we have 100 keyframes to animate on. And now let's jump into the creation of the particles. So what I want to do next is create a flip source object, which is needed for a flip simulation. Flip is a kind of particle system. So you just need to define your source, which is this guy now. And then I want to create a pop net. And this goes into my first slot. And I don't want to sim it right now. So this is now currently just generating particles. As you can see, that is working very nicely. But in the PopNet, I want to convert the solver to a flip solver. Right now, it's a pop solver. So I can delete all these objects here. I just want to change the simulation type to a flip solver, which is liquid, like that. And I do a flip object as well, like that. This goes in the first one. If you hit Y, you get the little scissor, and you can actually cut connections. And let's just hook it up like that. And let's see if I hit play now, what do we get? We get lots of particles up there. Make sure you remove the default fluid path in here. And I also want to copy the particle separation parameter. So I just copy this. I hit U to go up. I go to my flip source and I paste it into particle separation as a relative reference. So they both share the same parameter, which is important. Before we do that, let's just actually see what our voxels look like. And you can see they are very, very large. So we need to reduce our voxel size to maybe 0.5 and see what we get now. So this is still very blobby. So let's go a bit lower, maybe 0.02. And now we have a good detail on our particles, I say. Let's just go one lower and then we are done. That's perfect. So now our emission or voxel grid is fairly small and we get nice detail from it. Maybe it's a bit too much. Let's go back up to 2. Yeah, this should be enough. And then we look at our PubNet again, which still generates our particles like so. And in the PubNet, what we can do now is just reduce our particle separation to maybe 0.5. So now we have smaller particles to begin with. And now we would need to create some gravity. So we just create a gravity force at the bottom here. So now the particles should fall down, which they do, but they fall and fall and fall. So the next thing for us to do is make sure we have a collider. So in the flip object, you can actually let it collide to a certain boundary. And right now our boundary is super large. Let's just enable it first. So we just want it on the ground plane. So we don't care about the sides. We only want to enable the negative Y, which is the bottom floor. And let's go once on the second frame. And let's just change our scale of the velocity of solver grid under particle volume motion, volume limits. You can change the scale of it. So let's just keep it fairly small. This is now too small, but it's actually pretty good. Let's just scale it up a bit. So let's just move it up by a factor of 0.5. So we know it's at on the bottom grid. And then just hit enter. You can actually scale it a bit more user-friendly in the UI. If you select the right handles there. So now this is my top, and then I can just scale the sizes by holding shift. You can scale both sides at once like that. So this is now my optimized flip solver grid. If I hit play now, you should see the particles are falling and hitting the surface and then dying on the edges, which is perfect. And in my flip object, I can convert or change the look of those particles from sprites to particles, and I actually see something more liquidy-like. So now I can see how it's falling, how it's moving, and everything feels like it's kind of working. In our flip or pop source, we can also make sure we use all points. So this is using all the points within the within our particle system. But now we lost quite a few, and the problem is, I think, because our particle separation is still too large for this. So let's go lower, maybe 0.02, and now we can see that we get the particles back, which we had before, like so, and now they are emitting pretty nicely. It's a nice detailed stream of particles. We can go even lower if you want to have more quality. Let's just have a look at the spheres quickly, just see if they have a good separation, because if they are too small, they might not work good enough. So we can actually just increase our particle radius scale a bit, so we get larger spheres. Something like that should do a bit better job, I think. Maybe 0.5. And let's switch it back to particles. All right, so now we have our particles stream, and now we want obviously a colliding mesh. So before in the video we have this little shadow ball, and we want to use that too. In order for this to work properly, we need to have our simulation use voxel like VDBs as well. So I could use a geometry collider, but it's not as fast, or I think it's not as fast as a geometry approach. So what we can do here, we can just create a null, which is our output null. So the idea of this is that nothing should be connected after an out null, or just a null in general. You can just do maybe out collider, whatever you want to call it. And then in here you want to do a VDB from polygons, like so. And then we just want to convert that maybe 0.05. So this is now our polygons, but it's not as detailed as we wish. So maybe 0.2. What does 0.1 look like? This is very detailed, and I think this is good enough. It's fairly accurate to what we have right now. We can just keep it at that maybe and see what we have in our, let's see what we have and how it looks within our sim actually. All right, so let's load in a static. Let's go into the PubNet actually, and go in here, go to the first frame, create a static object on the left maybe, and also a static solver. They go hand in hand. You can have several static objects and you can merge them all together, and then they all need to go into the static solve. And then we just want to merge all that together like so with our flip solver, and this goes into gravity like that, just nice and straight lines like so. This one can go here, and then in a static object we want to make sure we select our subpath, which is in the collision, which is the out collider, which is now connected. We don't want to display the geometry, but we want to display the collision guide, which is this guy, and we want to make sure that its a mode is a volume sample. So now it's actually reading the VDB, and I think that is fairly accurate to what we need it to be. So if I hit play now, the particles are colliding with our sphere, which is perfect, and that's exactly what we are going for. And if I play this back, you can see everything looks nice and smooth now. So this is kind of the way to have it collide with objects, and we can definitely play a bit more about the particle separation. We can go low as 0.01 and see how that would look like. And also, if you have a strong GPU in the solver, within the solver tab you have use OpenCL, which is a bit faster calculation if you have a good GPU on it. So let's just run the sim and see what that looks like. So here's a cashed out sim. So this is what we have with no varying viscosity. This is just the default solver for the water, or I guess the flip solver, its default settings. You can see the water is it's going over the border, so they are dying after they hit the border, which is good. It speeds up the sim because I don't need to care about particles which are outside the boundaries, and that's fairly efficient to do that actually. So the next thing would actually be to work on a bit on the viscosity. To set it up, it's fairly easy. You would just go into the flip object, and you would go to initial data, and you want to add viscosity attribute. And if you go to physical, you can change the viscosity. Let's say we want to go for 1,000 or something like that. And in the flip solver, very important is to enable it, viscosity by attribute. And if I play this back now, we should have a thick liquid, which is very viscous, which looks like this now. So we have now a thicker liquid just based on that. So you can see it's now behaving very different than we had before. And now what we want to do is we just want to add a variation to all of that. So within our geometry spreadsheet, which is just a list of all the attributes on our simulation, within flip object and geometry, you can see all the things which live on the particle. It's quite a few things. Let's just hide the stuff we don't want. We just want to see viscosity, and let's say we want to see age as well. Right now the age is not really changing, it's kind of constant per particle, and we want to change all this stuff up. Viscosity is actually on 1, which is weird. It should be on what I've said here. I'm not sure what that is, but we will fix that anyways. So first of all, let's just make sure we get age on it. So in the flip solver, within the particle motion, we have add ID and age particles, and we want to use both of these guys. And we don't want to reseed particles, so we can just disable that for now too. And now we should have, if I start again, we should have the age increasing and the viscosity, right? So that's all we need. We don't need that. And what we can do now, the next step would be to actually vary the viscosity. So we can create a pop wrangle, which is a vex operator which runs on this current simulation and which will affect the particle's motion. So we want to connect this up to particle velocity, and in here it's fairly easy. What we can do, if I do f float at viscosity equals 2, for instance, we can see that now in my spreadsheet here on the left, the viscosity is now set to 2. If I set this to 2000, it's very thick liquid, it's on 2000. If I hit simulate now and look at this in the scene view, we get a really thick stream of particles, and you can see now it's almost solid, it's almost not bending anymore. So this is kind of the effect which we are going for, right? And we just want to vary that. So that's super thick caramel or whatever you would think it is. Yeah, so let's try to vary this. So there's quite a few options to do so. You can just use a random viscosity value. Let's just maybe create a default, which is, let's say 0.05 for water, something like that, as I think is water. And we can also just do a random one, so we can base it off on PT num, which is the overall particle number. The problem is it might change, right? The overall particle number might change. So we can actually try using this with ID instead, which is the particle ID. And so this is a random value between 0 and 1. And we want to fit that value between, let's say, a different range. So our input is our random number based on particle ID. And we want to randomize it. Let's say we want to go from 0.005, our initial one, and let's say we want to go up to maybe 1000. And let's just comment this guy out. Let's just call this our float rand viscosity, like so. And now we calculate that value, and now we can just cut this, have this in the top row, paste this here, and have this call or add our rand viscosity right here, like that. So now let's check the spreadsheet. Next frame. And now you can see we have a random viscosity, which is driven by ID, and it's random between the range we specified. So we have 1000 and we have 0.05 Not sure why we don't have lower values than that, which is interesting. Maybe we just need more samples. We should be able to have lower values than this actually. 0.05, not sure exactly why this is not going lower, but anyways. So now you can see we have that simulation, and we have thicker and more liquidy particles. This might be still a bit too much, so we can just change our range to be maybe not as thick as we had, but maybe just go up to maybe 50, and let's see what this looks like. Yeah, so now it's a bit softer, it's a bit more caramel-like. It's not as like a thick object as we had before. All right, now let's use age to actually specify how we want to control this, right? So that's why we had our default viscosity on the top, and we want to keep that actually up here, which is, what did I say? It's 0.0005 for our default viscosity. And now we want to do an if condition, if else loop, which looks like this. So if, and then we have a condition. If this is true, then the curly brackets are executed. And we have the at age because we write that, we're writing that out, right? So we have, if we go one frame next, we have our age in here, and we can just say if age is larger than maybe 1, age starts obviously on 0. So if age is larger than 1, we want to do our fancy random code here. So we just drop this in here, and now we can have a look what we get now if I play this back. So you can see age is 0.03, 0.04, and once it gets over 1, the viscosity should be changing. You can see how it's changing, and all of a sudden the viscosity is 20 or something like that, right? So if I check the render or the scene, you can see now after 24, which is 1 second or 1 unit, our particles immediately start to age or get viscous, right? You can see at the bottom here how they get more solid and they almost stop moving. And now we can change that, the age, right? We can also have a random value here. We can fit a range between maybe 0.08 and 1.2 or something to get a random age, and we can easily do that by just typing float age range maybe, and then we just create a random value based on ID as well, and we just range that between yeah, let's just do that. Let's just do a same thing as we did at the bottom. We can just copy this actually like that. And let's just do ID +1 to have a unique ID. And we just want to move that in a range of maybe 0.08 and what I say 1.2. So that is our age range. And we can also visualize it, right? If you don't know what it is, you can just quickly do that, which will always help. If you type F at temp maybe, like that, and in the spreadsheet you can now actually see what that looks like. Our temp is now 0.08 and 1.1, so this is a constant we have, and now we have a random age per particle ID, right? So if particle 3 gets older than 0.08, then the viscosity changes, and that's kind of how you do some randomization too. And you should be able to see that not all particle viscosities change at once. So this is not, these have changed now and the other ones have not. So this is kind of pretty nice to get some randomization there too. And that's how it's set up, right? And then you can go crazy on the viscosity if you want. You can change your age ranges. You can say, okay, let's start already at 0.05. So now they start changing viscosities a lot earlier. So let's just sim it and see. All right, so now we have a pretty cool sim already, and you can see now how it gets more viscous as it gets older. And what you can do to get an even more interesting result is you can also have another loop in here, which is saying if particles are even older than that value, let's say our range stops at 1.2, which is 24.5 frames or something. Let's say we go for 2 seconds, so after frame 40, 8, which is, let's say 2, if age is larger than 2, we want to change viscosities again, and we want to go from maybe 0.1. Let's actually start from the max. Let's go from 50 up to maybe 1500. So if age is larger than that, let's see how that looks, and let's just sim it and see what we get. Alright, so here's now a sim. I just disabled the collision grid just to see what we have, and you can see now how nice and solid the particles get. And we can also visualize the viscosity if you want. So you can go to the flip object within guides. We are right now visualizing velocity, and we can actually detect the range, so we can see how slow they get. But the more interesting thing is you can also look at the viscosity. Viscosity like that, and we can detect the range, but you can also say, okay, whatever is larger than 1000 should be white. So right now nothing is that thick. Only after a certain time you can see how they get really solid, and you can see this is working very nicely. So we can go down to lower values, or let's just say detect the range, and then you can see how the viscosity is changing. And I think this works fairly well, and you can see how all that is going on. Let's just go back to velocity and detect the range maybe, and then we can see how they get slower over time. So this kind of is the first part of this tutorial where I'm showing you how to set up varying viscosity, and in the next part we will actually be using creating the meshes. We are transferring the attributes onto the mesh so we can actually render this in the end. And before we finish off this part, please check out my Patreon channel. You will be able to follow along. You will be able to download all the source files and just follow along. You can see how I did all that, and just learn and try to replicate it and whatnot. So I really appreciate your support on Patreon, so please find the link at the end of the video. So thank you guys for watching this episode, and I will see you in the next part.